Section 1.2, Graphs of Equations. Every journey begins with a first step, unknown. So a relationship between two quantities is expressed as an equation in two variables. An ordered pair is a solution or solution point of an equation in xy when the substitutions x equals a and y equals b result in a true statement. And then the graph of an equation is a set of all points that are solutions to the equation. So first we need to see when an ordered pair is a solution to an equation. So if we look at letter A here, we have 3 and -5, and the equation is y equals 14 minus 6x. So what I can do is I can recall that this is x and this is x and this is y. Okay, so to check if it's a solution, what we do is substitute for y -5, and for x we substitute a 3. Then we simplify. -6 times 3 is -18. So we get -5 is equal to -4. Notice that that's not a true statement. So we say that the point 3, -5 is not a solution to the equation y equals 14 minus 6x because it gave us a false statement. This is false. So let's check letter B. Same equation. So here y is 26 and x is -2. -6 times -12 is +12. So we end up with 26 is equal to 26. This is a true statement. So we say the point -2, 26 is a solution to the equation y equals 14 minus 6x. Okay, so one of the things that we'll be doing a lot this semester is graphing. So I'm going to show you one method of graphing, and then throughout the semester, you'll learn new methods, which then you can decide which method is best for you. So this one's called the point plotting method. And basically, when possible, you want to isolate one of the variables. You want to construct a table. You want to plot these points and then connect the points. So it's important that you use negative values, 0, and positive values. So for example here, I'm going to choose -2 for x, -1, 0, and 1 and 2. You can choose as many points as you like that will help you draw the graph. For most of the equations, you need at least 4 numbers. If it's a line, which we'll talk about later, then you just need 2 points. So basically, x is an independent variable. You can choose whatever you want for x, and then y is going to depend on what you chose for x. So here we have our equation. First, we can isolate one of the variables, y, for example. So I'm going to subtract 3x on both sides. So I can then use this equation. So if I plug in the -2, then we get y is equal to 8. And so our ordered pair is -2 and 8. Then I can do the same for the rest of those numbers. So I'm going to plug in -1. So that becomes +3 times 2 or +2, which is 5. And then 0. If x is 0, then y will be 2. Okay, so then the next one, y is equal to negative 3 times x, which is 1. And that gives us a negative 1. And then last, if x is 2, then we get 2 and negative 4. So once we have our ordered pairs, we can come to our coordinate plane here and graph these. So x is negative 2. 1, 2, 3, 4, 5, 6, 7, 8 will be about here. Negative 1 and 5. 0 and 2. 1 and negative 1. And 2 and negative 4. Once we have our points, then we can graph our equation. By connecting these dots. And since we can choose any points for x, this is going to go to infinity. So we add the arrows at the end. Let's try one more. So here I'm going to pick for x negative 2, negative 1, 0, 1, and 2. In later sections, you'll be able to look at this and sketch the graph without having to draw a table. But for now, we can stick with the table. So here we have y is equal to negative 2 squared plus 2. Negative 2 squared is 4 plus 2, which is 6. If I plug in a 1, negative 1 squared plus 2 would be 1 plus 2, which is equal to 3. If I plug in 0 for x, we get 0 squared is 0 plus 2. So my ordered pair here is 0, 2. And last, if we plug in a 1, then we get that y is equal to 3. And if I plug in a 2, then I get 6. So let's plot the points. We get 2, negative 2, and 6. Negative 1 and 3. 0 and 2. 1 and 3. And 2 and 6. And so if I connect my dots here, then we get what we call a parabola, which we'll learn more about in chapter 2. Okay, so let's go to the next one. Y equals 4. We can create our own table. So let's say x is negative 2, negative 1, 0, and 1. So if you notice in the equation, we don't have an x. So what they're telling us is no matter what x you choose, your y is always going to be 4. So if x is negative 2, y is always going to be 4. And no matter what the x is. So we plot this in, we get negative 2, 1, 2, 3, 4, negative 1 and 4, 0 and 4, 1 and 4, and so on. So if I connect my points, then we get a horizontal line at y equals 4. So anytime you have y and a constant, it's going to be a horizontal line. And then on the next one, we have that x is 3. So no matter what is going on, your x is always going to be 3. So in this case, y can be anything, but it doesn't matter because x is always 3. So if we plot this, we go x is 3, and y is negative 2, negative 1, and so on. So this becomes a vertical line. Oops. And so anytime you have an equation such as this, where you have x is equal to some number, a constant, then you're going to have a vertical line. So let's go to the next page. The intercepts of a graph. And so now we'll learn a second way of graphing these equations. But first, let's look at what an intercept is. So these are points at which the graph intersects or touches the x and y axis. We call them intercepts. The x-intercept is the x-coordinate of a point where the graph intersects the x-axis, and the y-intercept is where the graph intersects the y-axis. And then we also call something called the zero. A zero is the x-coordinate of a point where the graph intersects the x-axis. Notice that it's the same definition as number 2. So these are the same definition. And so we call them x-intercepts or zeros when they're crossing the x-axis. So example 5, identify the x-intercepts, y-intercepts, and the zeros. So the x-intercept is where the graph crosses the y-axis, the x-axis. So this is my x-axis here. And notice that the graph is crossing at 2. And so this point here is 0 and 2. The y is 0, and then we have a 2. And then the y-intercept is where it crosses the y-axis. So here is our y-axis. And notice that the point is at 0, -2. Okay, so this is 0, -2. And I wrote this incorrectly. This should be 2 and 0. Okay, and then the 0 is also this x-intercept. So that's going to be the same as your x-intercept, which is at 2 and 0. And so we go to the next one. Here we have 2 x-intercepts, and they're both located at, well, one is located at 1 and 0 right here, and the other is located at -3 and 0. And then the y-intercept is going to be this point up here, which is at 0, +3. And then your zeros are going to be the same as the x-intercepts. This is a different name for them, but they're the same. And then on the next example, we have that the x-intercept is at 0, 0. Notice that's the same one for the y. And then the 0 is the same. Here, this is your x, this is your y. So the x-intercept, notice that the graph does not cross the x-axis. So we say that there's no or none x-intercepts. And then the y-intercept is located here, which is at 0 and 2. Since there's no x-intercepts, the zeros is the same. The graph does not cross the x-axis, so this is none. Okay, notice that in all the x-intercepts above, here's my x-intercepts. The value for y is 0. And notice that then the y-intercepts, the value of x is 0. So to find the x-intercepts, we're going to let y equal 0. To find the x-intercept, we let y equal 0 and solve for x. To find the y-intercept, we let x equal 0 and solve for y. So that's how you find these intercepts. So for example, it says find the x and the y-intercept. So first I'm going to find the x-intercept. So the steps are to let y equal 0 and solve for x. Okay, so your equation is y equals 3x minus 2. We're going to let y equal 0 and solve for x. So I'm going to add 2 on both sides. So x is 2/3. So my x-intercept is 2/3 and 0. And now I'm going to find the y-intercept. So for the y-intercept, we let x equal 0 and solve for y. So x is 0. So 3 times 0 is 0, so we get -2. Okay. Then if you need to, you can plot some additional points. But you're going to see in the next section is that since this is going to be a line, you really just need 2 points. So we have 0, -2, which is right here. And then we have 2/3 and 0. So that's going to be somewhere in here. And then we can graph the line. Okay, so let's try example 7. We'll find the x-intercept first. So for the x-intercept, remember we're going to let y equal 0. So notice they have x's in common, so I can factor out an x. And I can use a 0 product property. So I can say x is equal to 0 and 0 is equal to -x minus 5, which means I can put these factors equal to 0. This is going to still be x equals 0. I'm going to add 5 on both sides and divide by -1. So we get two x-intercepts. So x is 0 when y is 0, and x is -5 when x is 0, when y is 0. So the y-intercept, so here we let x equal 0, so y is 0. So plot these points, 0, 0, -5, which is right here. And so you only get 2 points. So here we need more points to help us know what the graph is going to look like. So I want to know what happens between these 2 points. So if x is -1, let's plug that in. -1 squared is +1 times negative is -1. Negative negative is positive. So we get 4. And if I plug in 2, -2, we get -2 squared is 4 times negative, and this would be +10. So we get 6. Okay, so -1 is 4, and -2 is 6. So somewhere up here. And then -3 is the last one. So -3 squared would be 9. Times negative is -9 plus 15. So we get 6. So this is going to be a parabola that goes up and then it comes down. So again, if the graph is not aligned, then that's important to have these extra points.